For 3 wars, American soldiers wanted it gone, a weapon born from desperation, the M1 Carbine. Its story begins in the shadow of World War II with a new German tactic, Blitzkrieg. Panzer divisions didn't stop at the front line, they punched through, deep into the Army's rear. Suddenly, the line between combat and supply vanished. America's best infantry rifle, the M1 Garand, was a masterpiece of engineering. So why did it become a strategic liability? The answer was the speed of the German advance. Millions of soldiers were now targets: drivers, mechanics, ammunition carriers, clerks, the logistical backbone of a modern army. They were not infantry, but German armor made no distinction. Their weapon was the heavy 9.5-pound M1 Garand, a rifle designed for a trench, not a truck cab. For a driver, it was a constant burden. The long barrel jammed between the seat and the door. An ambush hits, he can't deploy it. The metallic clang of heavy rifle butts on steel truck beds became the sound of a fatal design flaw. In this new mechanized war, for every single man on the front line, there were up to 10 support troops behind him. 10 men suddenly needing a weapon they could actually fight with. A pistol was not enough. The War Department made the need official. It issued a formal requirement for a new, lightweight shoulder weapon. The Ordnance Department's new requirement was not a request. It was an ultimatum. The company Winchester received the contract. The deadline? 13 days. The target weight? 4.5 pounds. This was almost half the weight of a standard service rifle. An engineering absurdity. Their solution was not innovation. It was archaeology. Engineers pulled a trigger mechanism from a Winchester Model 1905, a civilian design already decades old. They scavenged, they combined, they cannibalized. A modified gas piston, a trigger group from a forgotten rifle. In the workshops, the air was thick with gun oil and tobacco smoke. For 13 days, they built a Frankenstein weapon from spare parts and sheer will. Winchester's lead designer, David Marshall Williams, called it impossible. He quit the project, but the engineers kept working. They delivered a functioning prototype on the final day. Seeing the impossible was now a reality, Williams returned to the team. The rushed prototype was complete. Now it had to survive the U.S. Army's formal judgment. The destination? Aberdeen Proving Ground. For 3 days, the Winchester rifle dominated the trials. It outperformed every other design. Then a sharp metallic crack. The bolt fractured. Inspection revealed a flaw in the steel, not in Williams's design. But the Army was unmoved. The Ordnance Department's ultimatum was brutal. Replace the part in 24 hours or be disqualified. The rifle itself was forbidden from leaving the proving ground. How do you save a failing project without blueprints? Winchester's engineers would machine a new bolt entirely from memory. In a single night, a team raced back to the factory. They had no schematics, no technical drawings, only the memory of the part's shape and dimensions. Machinists worked through the darkness, carving a complex piece of hardened steel based on recollection alone. They returned to Aberdeen at dawn, carrying a component they had no way of testing. It was installed. It held. The rifle passed the remaining tests. It earned its designation, the M1 Carbine. The Commission's vote to award Winchester the contract was 100%. Winchester's design had won the contract. But the weapon carried a flaw from its very conception, a flaw demanded by the Army itself. The specifications were approved back in June 1940. They were built around a brand new cartridge, the .30 caliber round from Winchester. On paper, its power seemed adequate, roughly matching a .357 Magnum handgun. But compared to the main battle rifle, the M1 Garand, the numbers told a different story. The carbine's bullet delivered just 36% of the Garand's muzzle energy. The round was small, more like a powerful pistol cartridge than a true rifle one. This was a deliberate compromise. The weapon was never for the front lines. It was designed for support troops who needed something lighter than a full-sized rifle. Firepower was sacrificed for weight. But this reduction in energy meant the bullet often failed to penetrate an enemy's thick winter uniform, a critical failure. For its intended role, the compromise was accepted. This calculation would prove fatally wrong. The ballistics were secondary. The Army's mechanized legions needed millions of weapons for their support lines, and the order went out to the civilian sector. The scale of production was immense. Who armed the largest supply army in history? Factories that made typewriters and jukeboxes. Companies like IBM and Rockola were pulled into the war effort. The rhythmic thud of heavy industrial presses, once stamping out jukebox casings, now shaped steel. Thousands of rifle receivers, stamped, stacked, and shipped. The logos of peacetime America, marks of office machines and music players, were now pressed into the metal of military hardware. This was the arsenal of the rear echelon. It demonstrated the very structure of the American war machine, a logistical tale far larger than its combat teeth, and the numbers proved it. By the war's end, over 6 million M1 carbines had been produced. It became the most manufactured American small arm of the conflict, more than the 5.5 million M1 Garands for the front lines, more than the 1.3 million Thompson submachine guns. Immediately after mass production began, the carbine faced the brutal reality of a global war, where its first critical combat tests awaited. The first critical test came in the Pacific Theater. In the jungles of the Philippines, theory met reality, and the reality was failure. Why did multiple hits no longer stop an attacker? The answer was written in blood. A soldier fires, a dull thud as the bullet impacts. The enemy stumbles but does not fall. He keeps coming. The American fires again, another thud, another. The target is still moving forward. The carbine looked like a rifle. It was supposed to perform like a rifle, but its bullet lacked a rifle's authority. This brutal contrast became doctrine in the field. Reports from soldiers were unanimous. The weapon was not enough. The enemy's physiology was also part of the equation. Japanese soldiers received stimulating tablets, officially called Philipon. It was a military-grade methamphetamine. The drug erased pain, suppressed fear, and created attackers who could absorb hits and continue their charge. The .30 caliber round simply lacked the energy to overcome that chemical momentum. Faith in the weapon evaporated, so troops started making their own choice. They began discarding their issued carbines, seeking out the older, heavier M1 Garands wherever they could find them. The rejections became a pattern. Reports from the Normandy beaches mirrored complaints from the Pacific. High command was forced to investigate the weapon's mechanics. The problem was the bullet itself. A full metal jacket design, mandated by the Hague Convention of 1899, it was built to pierce, not to expand. The projectile passed cleanly through soft tissue. It did not tumble. It did not fragment. The bullet exited the body, still holding most of its kinetic energy, leaving a narrow, insufficient wound channel. The result on the battlefield was catastrophic. An enemy could absorb multiple hits and keep fighting. One veteran reported firing 4 rounds into a German soldier during a charge. The man never stopped. After landing at Normandy, another soldier threw his carbine away. He found a Thompson submachine gun. He finished the war with it. This was not opinion. It was a frontline consensus. The backlash reached the highest levels of command, and the complaints could no longer be dismissed. Reports documenting the carbine's lack of stopping power were formally filed. The reports were filed. The data was logged. But the production lines had already delivered millions of carbines. How does a bureaucracy handle a weapon it cannot recall? It finds a new mission for it. America's main battle rifle was the M1 Garand, over 5.5 million produced. Its submachine gun was the Thompson, at 1.3 million units. Both were heavy. Both were long. Paratroopers needed something else, something compact for the jump. The solution was the M1A1, a standard carbine retrofitted with a side-folding wire stock. A sharp metallic click from a spring-loaded cam locked it open. Folded, it was just 25 inches long. By 1943, the carbine found its new home. With the airborne divisions invading Sicily, the logic was a compromise. For frontline infantry, its stopping power was a liability, but for specialized troops, its size was an advantage. The weapon was issued in a padded scabbard, designed to be strapped to the leg. A bad idea. A hard landing with a rifle strapped to your thigh meant a broken bone. So the soldiers improvised. They tucked the carbine behind their reserve parachute just before the jump. But battlefield fixes could not solve a design flaw. The problem demanded a new doctrine. By late 1944, the Ordnance Department had an answer. Not a better bullet, more bullets. The automatic M2 carbine. Its development was a direct response to the German STG-44, a tactical shift for the entire U.S. Army, a rate of fire of 750 rounds per minute, fed by a new 30-round magazine. But production only began in April 1945, too late for the war in Europe. A new theater required an even greater escalation. The solution was the M3 carbine, an M2 fitted with a primitive infrared scope. Its price of innovation was weight, a massive 30-pound battery pack carried on the operator's back through the humid air of the Pacific Islands. This technology was forged to counter a specific threat: Japanese soldiers, masters of night infiltration. They slipped through American lines in total darkness, causing chaos, sowing fear. The invasion of Okinawa. A three-man team moves through the pitch-black jungle. One soldier carries the M3. Another lugs the heavy power source. The operator raises the weapon. Through the eyepiece, the night becomes a ghostly green landscape. He sees movement, shapes detaching from the shadows. He opens fire. Tracers cut through the dark, marking targets for his squad. The ambush is absolute. Only 150 M3 carbines were deployed for the invasion. It was America's first combat use of night vision technology, and in the first week of fighting, these systems accounted for an estimated 30% of all Japanese casualties. The high-speed M2 carbine, now America's standard, met a new theater of war, the Korean Peninsula, and with it, a new enemy the weapon was never designed to fight: the cold. The technological edge gained on Okinawa disappeared in the ice. A catastrophe unfolded. What is the price of an automatic weapon's climatic vulnerability? 30% of carbines failed in battle, according to company commanders. The .30 caliber rounds reportedly failed to penetrate the thick quilted winter uniforms of Chinese soldiers. A weapon designed for 300 yards was only effective inside 50. 95% of all targets were dropped at point-blank range. The fighting around the Chosin Reservoir pushed temperatures to -34 degrees Celsius, conditions far outside the Ordnance Department's original tests. Soldiers needed to fire between 5 and 20 warm-up shots just to cycle the action on full auto. The weapon was compromised. The intricate mechanism, designed for rapid fire, became its greatest liability. Frost and ice crippled the system. Dust and moisture had been a problem in hot weather. The cold was fatal. Standard military lubricant froze solid inside the action, and the weapon's weak return springs lost their elasticity in the sub-zero air. The bitter Korean cold revealed a fundamental Pentagon error. A weapon designed for comfortable rear echelon duties was now on the front line. At -35 degrees Fahrenheit, the core of the problem was the propellant, WC-820. A double baseball powder that bled energy with every drop in temperature, far more than the powder in the M1 Garand's ammunition. This created a catastrophic chain reaction. First, the standard lubricant thickened into sludge. Then the chilled powder failed to generate enough gas pressure. The bolt would not cycle. It froze shut with a sharp metallic clang. The M1 Garand also struggled, but it had a brutal advantage. Its long-stroke gas piston system carried immense power. A swift kick to the operating rod could break the bolt free. The carbine, with its weaker cartridge and short-stroke system, had no such margin for error. It simply stopped working. But a far worse problem emerged. Why didn't the bullet stop the enemy? The double base powder was critically losing pressure in the cold. A temperature drop of 103 degrees from initial testing conditions crippled its energy output. Soldiers would hit a target in the chest from 25 yards. The man would just flinch and keep coming. Confidence in the weapon evaporated. Some units issued a desperate standing order for carbine users. They were to aim for the head, not the center of mass. The story from the front lines was simple. Thick Chinese uniforms, frozen solid, were stopping American bullets. A convenient myth, a battlefield legend. Modern ballistics proved it was a lie. The experiment was direct. 8 layers of thick terry cloth, soaked in water, then frozen solid. The round pierced the ice. Then it tore through the equivalent of 21 inches of ballistic gelatin. 7 gallons of water. For perspective, the FBI standard considers 12 inches of penetration the minimum to guarantee reaching vital organs. The carbine delivered almost double that, after breaking through ice. The problem wasn't the weapon, it was the soldier. A documented phenomenon known as marksmanship degradation. Under the stress of combat, troops simply convinced themselves they had hit their mark. But in the field, perception was irrelevant. The weapon was failing its users, and the users were failing the weapon. Support troops, clerks, drivers, mechanics, were thrown into ambushes. Close combat they were never trained for. Their complaints about the carbine were echoed by an unlikely source. Captured Chinese soldiers, armed with the very same captured rifles, shared the critique. The stopping power was insufficient. The command had to adapt. A new universal rifle was still years away. 20,000 M3 systems were deployed. A solution with an infrared scope, but a range of only 125 yards. Each scope was tethered to a heavy battery pack, a dead weight pulling a soldier down in a frozen defensive pit. In the extreme cold, troops learned to strip all lubricant from their weapons. Metal on raw metal, just to make it fire. The M3 was not for attack. It was for static defense, to locate enemy patrols attempting to infiltrate in darkness. As the front stabilized, the carbine's role was solidified. The weapon was now officially used as it was originally intended, for defense. What was a liability in the Korean mountains became a geopolitical asset in Southeast Asia. In 1956, the M1 Carbine found a new war, a new jungle. U.S. military advisors arrived in South Vietnam, and with them came the guns. Initially, 800,000 M1 and M2 carbines flooded the country, becoming the most common weapon in the hands of the South Vietnamese army. But why did these soldiers refuse the more powerful M1 Garand? The reason was simple. For a soldier averaging 5 feet tall, the Garand was a burden. The carbine was a natural extension of the body. In the humid, suffocating air of the jungle, its short barrel never snagged on dense vines. Mobility was life. Firepower was secondary. From American warehouses, the carbines moved to makeshift workshops. Vietnamese soldiers sawed off stocks. They shortened barrels. They customized the weapon for close-quarters combat. By the end of the war, the number of carbines left in Vietnam was staggering. 1.5 million. But a new rifle was coming from the north, the Soviet AK-47. Its 7.62 millimeter round was 60% more powerful, rewriting the global balance of infantry power. A new equation of power. This forced the United States to accelerate its own replacement program, introducing the M16 in 1964. The carbines era was over. By the 1970s, the weapon was almost entirely out of American service, but the carbine's final chapter was not written in the jungles of Vietnam. Its fate was sealed decades before, by diplomats in a palace in Europe. The core problem was the bullet itself. The .30 carbine used a full metal jacket round. It was too fast to act like a heavy pistol bullet, like the slow .45 ACP that crushed tissue. It was too slow to act like a true rifle bullet, which yaws in fragments at high velocity. The result was a compromise, a failure. The bullet passed straight through the target, creating a narrow wound channel, not enough to reliably stop an enemy. The solution was simple engineering, a different kind of bullet, one designed with a small, hollow cavity in its nose. When this bullet strikes soft tissue, the cavity fills. A hydrodynamic shock forces the metal jacket to peel open from the inside. The bullet mushrooms. It expands, slows dramatically, and dumps all its energy into the target. The wound channel is massive. The stopping power is absolute. Law enforcement could use this ammunition. The U.S. military could not. The Hague Declaration of 1899 was explicit. It prohibited any projectile designed to expand or flatten easily inside the human body. This single diplomatic act reshaped 20th century warfare. Armies could not seek lethality through expansion, so they sought it through sheer velocity, a path that would lead to the 5.56mm round. But for the M1 carbine, there was no path forward. For conventional armies, the ban remains.